Okay, today we're going to, in Chem 100, we're going to review for exam 9. This is the last regular chapter exam for this semester. And this exam will be on Thursday, this coming Thursday, May 1st. And since we don't have any new material to introduce on Thursday, the only activity on that day will be the exam. So what I'll do is I'll zoom in for the first 30 minutes or so in case anybody has trouble with getting into the online exam, and in case anybody shows up in person. And then I'll leave, but you can still get in touch with me on my cell phone if you need help. And then the following week on Tuesday and Thursday, I've set aside for review for the final exam. So we'll cover everything that we've done this semester and pick review problems from the review documents. And I'll be available for questions. All right, so chapter 18, electrochemistry. This first page, I think I picked all of them on the first page. This is number 1. Consider the following reaction. Which of the following statements is true? Right? Barium plus chlorine yields barium chloride. Okay. So if we look at each one of these statements, and let's take a look at the answers to see what the question is trying to get us to think about. Oxidation, reduction. Yeah. So why don't we do that assessment first? Remember how you do that. You need to assign oxidation states for each of the elements. This is a free element, oxidation state 0. 0. Chlorine in this case would be a -1. Barium would be a +2. Because barium, according to our rules, barium is from the alkaline earths, which is the second column, and that makes it a +2. So chlorine has to be a -1. Okay, so which one of these was oxidized? Let's draw our tie lines. Okay, remember, oxidation is loss. So who lost electrons? From 0 to 2+, barium was oxidized. That means chlorine has to be reduced. Remember, they always go in pairs. Oxidation, reduction, you can't have one without the other. Okay. So now let's look at our choices. The barium atom is losing electrons. Yes. Therefore, it is oxidized. That's true. Okay. Do we have any wonky ones in there? Well, we have none of these. We already found one. So if you're in a hurry on an exam, you found the answer, you can go ahead. So we must assume that the others, if we went through them one by one, they would each one be false. Number 2. In the reaction, calcium plus oxygen, calcium oxide, the calcium is. So we're looking at what's happening to the calcium. Solid plus oxygen, gas, yields calcium oxide. Solid, and there should be 2 of them, yes. Okay, so let's just make a habit of of assessing the reaction this way. All right, oxidation state 0, 0. 2 minuses and 2 plus. Because oxygen is always 2 minus unless it's in a peroxide. And calcium is an alkaline earth, so it has to be a 2 plus. So what's happening here? Is that the question? Yeah, calcium is what? It goes from a 0 to a 2 plus. It must be oxidized. Oxidation is loss. So there again, A is your best answer. Okay. Good. Three. In the reaction strontium plus fluorine, the fluorine is, okay, so we're going to assess this one again. Strontium, solid, plus fluorine gas yields strontium fluoride, solid. Okay, here again, elements are zeros. Fluorine is always -1. So that means strontium must be +2. Okay, so what happened to the fluorine? It went from a 0 to a -1. Its oxidation state decreased, which means we had to add electrons, which is reduction. Fluorine was reduced. Okay, number 4. The oxidation state of sulfur in potassium sulfite. Okay. Okay, so that's our target right there. We know that oxygen has to be a -2. And potassium is an alkali metal, so it has to be a +1. That means 2 of those means a +2 for this one and a -6 for that one. Okay. So far we have -4 that must be balanced by the sulfur. So the sulfur would have to be a +4. Okay. There again, your answer is A. Number 5. LiCl, lithium chloride. What's the oxidation state of chlorine? Well, lithium is an alkaline metal, which means +1. That means chlorine must be a -1. It's all about balancing the oxidation states. Okay, number 6. CO2. Okay. Carbon dioxide. This is a covalent compound. There are no ions in here. So we have to go back to our rules. Oxygen, in this case, is a -2, which means -4 total. That means carbon must be a +4. Okay. Oxidation state of carbon is 4. Left the plus out, but it's understood. Oxidation state of sulfur and sulfate. I'll just put it up here. SO4 2-. This is a polyatomic ion, you'll recognize. Oxygen has to be a -2 times 8 is times 4 is a -8. But we need to be sure that we have 2 minuses left over for the charge. So that means we only have to balance a -6. So that means sulfur is a +6. +6 minus 8 is a -2. Right? Number 9. H2CO3, which is carbonic acid. If it's aqueous. Right? We learned that when we named compounds. If it's not aqueous, which is unlikely, but if it were not, then it would be hydrogen carbonate. Okay. Question is oxidation state of carbon. Right. Hydrogen is a +1 times 2 is a +2 total. -2 times 3 is -6. This is a neutral compound. Right? So carbon must balance that -4 with a +4. All right. Number 11. What's the oxidation state of rubidium in a compound? Right? If it just said oxidation state of rubidium, it would be 0. But in a compound, rubidium is going to be, it's an alkaline metal, which means +1. All right. Next one is kind of a trick question. What's the oxidation state of oxygen here? That is a diatomic element. This is its most stable form at 1 atmosphere pressure and room temperature. So its oxidation state is taken as 0. Okay. 15. What do we have here? Magnesium, phosphate. Okay. What's the oxidation state of phosphorus? You have 2 options here. You can assess the entire molecule. We'll do that first. Magnesium is a 2+ oxidation state because it's an alkaline earth. So that means it contributes a +6. Oxygen is a -2. By how many oxygens are there? There are 8. 2 times 4 is 8. So 8 times -2 is -16. Okay. Phosphorus, there are 2 phosphoruses, but what we need to do is decide what oxidation state for phosphorus is required to balance a -10. Well, we have 2 phosphorus. So 2 would be equally divided -5. Okay. Excuse me, +5. That's a minus that we have to balance with a +5. Okay. The other way to assess this is to take that phosphate out. If you know that phosphate is 3-, and a -2 times 4 is -8, and we need to keep 3 minuses out, then a -5 is all that's required to give you a 3- charge. So either way, it gives you a +5 for phosphorus. Okay. Oxidation state of chromium in dichromate. Number 17. Okay. So this is a polyatomic ion, and the summation of the oxidation states must be 2-. So -2 times 7 minus 14. We need to hold two of those minuses out. So 2 chromiums split among 12 plus is +6. Each chromium has to be a +6. Okay, repetition. Go down here to 28. Right. In reacting, metal atoms characteristically do what? Metal atoms, when they react, tend to go to cations. Now that's if it loses 1 electron, it'll go there. If it loses 2, it'll go to 2 plus. This is just an example. So metal ions tend to become cations. Is that one of our selections? No. So let's take our selections. So A becomes anions. That's false. B, lose electrons. Yes. This one, in this case, this metal atom had to lose 1 electron to make that anion. So B is true. But notice E is 2 of the above. So we got to look for the others to see if any one of those others satisfies that condition. C says decrease in oxidation state. No, we get an increase. It goes from 0 to +1, right? So C can't be it. How about D, form covalent bonds? Metals do not form covalent bonds. Only nonmetals do that. Now, in this course, we don't study the metallic bond. It's not covalent, but it is unique to metals. And that's not part of our discussion. So our only choice is ionic bond or covalent bond. And they don't form covalent bonds. So that means E is also false. So the only one that fits is B. 29. Let's see. Let me refresh the surface here. Okay. 29. Which statement is true of the following reaction? Let's see, 2 potassium plus copper 2 chloride yields potassium chloride plus copper. Okay. We're identifying oxidation and reductions here, so let's draw our tie lines. Potassium goes from a 0 to a +1. Right? That's a loss of 1 electron per potassium. Equals 2 electrons lost. That's an oxidation. Right? What happens to chlorine? Nothing. Chlorine is -1 here, it's -1 there. So copper is the one that changes. Copper goes from a +2, right? 2 times -1 is a -2, balanced by a +2, goes to 0. This is a gain. 2 electrons per copper times 1 copper equals 2 electrons gain. That is reduction. Okay. So which one of these fits? Copper is reduced. Yes, that's true. So A is true. Okay. How about B? Chlorine is reduced. Well, you can't have both. You can't have, nothing happens to chlorine, right? Chlorine stays the same, right? So B is false. Potassium is reduced. If copper is reduced, something else has to be oxidized. Right? Potassium can't be reduced and copper reduced also. Copper is oxidized. No, copper is reduced. And E, chlorine is oxidized. Nothing happens to chlorine. So the only correct answer there is A, copper is reduced. Let's see. I put an extra one in there. Do we want to look at that one? Yeah, let's take a look at that extra one I threw in there on number 29. Okay, in this case, Cu2O plus H2SO4 yields Cu plus CuSO4 plus H2O. Yeah. Okay. So what's happening here? Well, notice that sulfate doesn't change. Sulfur stays within the sulfate here and here, so we can ignore. Sulfate is a spectator. Water is formed from the process, but it doesn't change. -2, +1, and +1. So this oxygen, let's see. Yeah, this oxygen and that oxygen, well, the sulfate, they don't change. Neither does the hydrogen. So what happens? Well, notice we got 2 coppers here and 2 coppers there. So it could go both directions. Right? This is 0. This is a 2-, so this has to be a +2. This is a -2, and 2 of them means that each one is a +1. So +1 goes to 0 means gain 1 electron per copper. And this one goes from +1 to +2. This one's a loss, 1 electron per copper. So we have reduction here and oxidation here. From one compound to an element in a compound. Remember what this is called? This is a disproportionation reaction. Disproportionation reaction. It goes both ways from the same source. All right. Number 30. In which of the following does nitrogen have an oxidation state of +4? All right, so there's A, B, C, D, and E. And we've got HNO3, NO2, N2O, nitrous oxide, ammonium chloride, and sodium nitrate. Okay, so we're looking for a +4 oxidation state. Right, we have a -2 here and a +1. So that's a -6 and a +1 yields a -5. So this nitrogen must be a +5. That's not it. This has a -2, it's a -4, plus 4. That's it. And considering the multiple choice here, if you're in a hurry in the exam, that's your answer. You just move on. But this is a -2. That means each one of these has to be a +1. This is a -1. This is a +1, which is a +4. And a -1 equals +3. This nitrogen is a -3. And this is a +1, -2. So we have a +1 and a -4 equals a -3. This is a +3. Okay. So the only one that answers that question correctly is B. Nitrogen dioxide. Okay. The 34. Which species is the reducing agent? So let's see, titanium chloride, liquid, plus oxygen yields titanium dioxide plus chlorine gas. Okay. So in order to identify the reducing agent, we need to find out which one was oxidized. This is 0. This is a -2. So if we connect these, we know that this one had to be reduced. Gain 2 electrons per oxygen times 2 equals 4 electrons. So this was reduction, which makes it the oxidizing agent. Is that the one we were looking for? No, we were looking for the reducing agent. Okay, so chlorine doesn't change from -1 to -1. Titanium does change. Titanium has to be a +4 here to balance those 4 minuses. This titanium is, oh, excuse me. I was wrong. This titanium is +4. It doesn't change. The chlorine goes from -1 to 0. So we're talking about a loss, 1 electron per chlorine times 4 equals 4 electrons lost. This is the chlorine is oxidized, which equals the reducing agent. There we go. Okay. That was D. The reducing agent is titanium chloride. Actually, you better say titanium 4 chloride. This is a type 2 compound. Okay. Number 38. In the reaction, P4 plus 10 chlorines yields 4 PCl5. Phosphorus is what? Okay. So if we go from P4 plus 10 chlorines yields 2 Cl5. Oops. 4, excuse me, 4. Yeah, 4 phosphorus, 20 chlorines. Yeah, that's right. Okay, so what happened to phosphorus? Well, it's a 0 here, and that's a 0 there. This is a -1, which means 5 times -1, this is a +5. So what happened when we went from here to here? That's a loss of electrons, which is oxidation. So phosphorus was oxidized. Okay, 39. What happened to chlorine? Chlorine went from here to here. We went from 0 to -1, which is a gain of 1 electron per chlorine, which is reduction. Chlorine was reduced. Number 44. In this reaction, magnesium plus sulfuric acid yields magnesium sulfate plus hydrogen gas. Which element, if any, is oxidized? Okay. Magnesium plus sulfuric acid yields magnesium sulfate plus hydrogen gas. And let's see. Magnesium, 2 hydrogen, sulfate. That's balanced. Okay, oxidized. That's a 0. That's a 0. This is a spectator. So if we go from here to here, +2, +1, magnesium lost 2 electrons per magnesium. That's oxidation. All right, so magnesium was oxidized. All right. Number 48. In this reaction, 3 copper plus hydrogen ions plus 2 HNO3, right? Yield 3 copper, 2 plus 2 NO plus 4 H2O. 2 plus, just checking myself. Yeah. Okay, so we're looking for the reducing agent. Which one was oxidized? That's 0. That's +1. That's -2 plus 1. So a -6 and a +1 yields -5. That means this is a +5. That's a -2. This is a +2. That's a -2 and a +1. And now we can assess the direction of electron movement. Copper went from 0 to 2+, which means oxidation equals reducing agent. Question was, yeah, species that's a reducing agent. That's copper. The hydrogen ions didn't change. Hydrogen ions from either source did not change. Nitrogen went from a +5 to a +2. So it was reduced. Equals oxidizing agent. Okay. Determine the coefficient for the iodide ions, 49. Okay, this one, we're actually going to have to balance the equation. Question is, do we need to use the tie line method, or are we going to have to go to the half reaction method? And I think we're going to have to go half reaction. And the reason being that there's an oxygen on this side and there's no oxygen on that side. So we're going to have to use half reaction method. Okay. This is 49. Give myself a lot of room. So out of this equation, on the shared page, yeah, let me go ahead and put them up here. And then iodide. We have chromium 3+. These are all aqueous. And iodine, well, except for the iodine. Iodine's a solid. Okay, so let's figure out which one gives us the reduction half reaction, which one gives us the oxidation half reaction. So if we've got a 2- here, that's a -14, but we had to hold out 2 minuses there, so that's a 12. And 2 into +12 is +6. Okay. Iodine's a -1, chromium's a 3+, and that's a 0. Okay. All right, so what happens when we go from chromium 6+ to 3+? That's a reduction. We had to add 3 negatives. So the reduction side is this species with a +6 here yields that species. That means iodide here yields iodine there. That's our oxidation. Okay, so what do we do next? We balance anything that's not oxygen or hydrogen. So we have 2 here, chromiums, we need 2 chromiums on that side. We have 2 iodines there, we need 2 there. Then we balance the oxygens. There are no oxygens here, so we don't have to do anything with this one, but we do need 7 oxygens on this side. Now we need 14 hydrogens. Okay. Okay, so now we can balance the electrons. We're going from +6. This is only +6. This is 2 times +6 is 12. Right? So if we go from here to here, that's a loss of 3 electrons per chromium, but there are 2 chromiums. 6 electrons were lost. Okay. And here we're going from -1 to 0. We had, excuse me, gain. I don't know what I'm doing. This is a gain of 3 electrons per chromium. There we go. That makes more sense. This one is a loss. 1 electron per iodine times 2 equals 2 electrons. So a loss here means we have 2 electrons on that side. Now we can balance. We just need the same number of electrons in each one. This one has 6. We need 6 here. So we're going to multiply by 3. Right? So that's 6. That's 6. That's 3. Okay. Now, if we were going to create a fully balanced equation, all we need to do in this case is just say, what's the coefficient of the iodide ions? Now that we can add them together, we just look for the iodide, and the coefficient is 6. Excuse me. If we were to do these others, then we would look for, say, chromium 3 plus. Right? Chromium 3 plus over here is coefficient of 2. And the coefficient of water, in this case, would be 7. Okay, now we can go to 52. For the reaction of sodium bromide with chlorine gas to form sodium chloride and bromine, the appropriate half reactions are oxidation first, reduction second. Okay, this is one of those cases where if you don't know how to write the compounds as named, then you're stuck. Right? If we react sodium bromide with chlorine gas, this is sodium bromide. This is chlorine gas. And this would be a solid. And it yields sodium chloride plus bromine. That's a liquid. Okay. So we want the half reactions. All right, what happened here? Well, we can balance this equation. We can pull out the half reactions. We don't have to use water, but since the problem is asking for the oxidation and the reduction half reactions, then we should pull them out. Right? That's 0. That's 0. -1 plus 1. -1 plus 1. Then they want oxidation first and reduction. Okay. We can balance this with half reactions, or we can use the budget method because we've got 1 sodium here, 1 sodium there, 2 chlorines here, 1 there, so a 2 here, and a bromine there, 2 bromines there, 2 here. So that's balanced. Which one is the oxidation step? Well, which one lost electrons? Sodium is a spectator. It didn't change. So bromine went from a -1 to a 0. Bromine lost. So we had 2 bromine ions, right? Yeah, 2 bromine ions. Okay. And it lost electrons to get to this point. How many electrons? Well, 1 electron per bromine, but we have 2 bromines. Oops. Plus 2 electrons. Okay. Now what happened to chlorine? Well, chlorine, 1 chlorine led to 2 chloride ions. but it had to gain 2 electrons, 1 electron per chlorine. So the oxidation step is 2 bromine ions yields bromine element plus 2 electrons. Okay. B looks like a candidate. Then, okay, we got a problem here with the typing. It's a typo. There's a space in there that shouldn't be there. Let's see if I can correct that. Okay. Oops. Okay. Let's see. Let's put a space here then. Oh, didn't like that either. All right, I'll have to fix it later. But 2 chlorines plus 2 electrons yields 2 chlorides. Okay, so B would be the best answer. Now, why did I do it this way? I did it this way because sodium is a spectator. It doesn't have to be there. We're only interested in that species being oxidized and this species being reduced. $56. All right. When the following reaction is balanced in acidic solution, what is the coefficient of water? All right, first of all, they're telling us that we may have to use the half reaction method because they're interested in the water coefficient, and there's no water in that molecule, but there is oxygen. So we know from that clue that we are going to have to use the half reaction method. All right, so this is the reaction as given. Nitrate. Okay. Zinc ion and ammonium ion. Okay, so let's assess this. That's a 0. This is -2 times is -6, -5 only needs to be balanced. That's a +5. All right, add them up and satisfy yourself. That's a 2 plus. We have a +1, it's a +4 total, but we hold one of those pluses out. So it's +3 that has to be balanced. That's a -3. Okay, so now which is the oxidation step? Which is the reduction step? Who was oxidized? Zinc went from 0 to 2 plus. Zinc is oxidized. Okay, that means nitrate, or the nitrogen in nitrate, must be reduced. It went from a +5 to a -3. So how many electrons is that? Well, +5 to 0 is 5 electrons, and 0 to -3 is 3 more, so that's 8 electrons. Remember that, we'll need it later. Okay, 1 zinc, 1 zinc, we're good. 1 nitrogen, 1 nitrogen, we're good. No oxygens, oxygens. We need 3 oxygens on this side. So we'll put 3 water. Now we have 6 hydrogen ions. There we go. Now, electrons. Oxidized. We lost 2 electrons here. Okay. For this one, we had a +5. Remember, we went to a -3. We had to add 8 electrons to get from a +5 to a -3. So now we balance the electrons. You have 2 there, 8 here. This equation can be match up the 8 electrons by multiplying 4. So 4 here, 4 here, and 8 there. Okay, now we can add it together. There are no waters up here, so when we add it together, the only water is going to be right there. So the coefficient for water is 3. Right. 58. Which of the following is true for a galvanic cell based on the following reaction? All right. We want to find out reduction, anode, cathode, that type of distinction. Okay. So let's put the equation up here. Zinc solid plus Cu2 plus yields zinc 2 plus copper metal. Okay. Now, as far as the zinc and copper go, this equation is balanced. 1 zinc, 1 copper. That's a 0. That's a 0. So let's divide it up into the half reactions. Okay. Which one was oxidized? Zinc was oxidized. Went to zinc 2 plus, which means it lost 2 electrons for each zinc. Okay. That means copper had to be reduced. Copper 2 plus yields CuO. That means we need 2 electrons for each one of the coppers. Right? So when we add them together, we get that reaction. To answer the questions, A, B, C, D, and E. A says zinc is being reduced. Is that true? No. Zinc is oxidized. How about B? Zinc serves as an anode. All right. What is our definition? Cathode is the site of reduction. And oxidation is the site, the anode is the site of oxidation. So is that true? Zinc serves as the anode. Yes, that's true. C, copper 2 plus ion is being reduced. Yes, that's true. Right there, it's being reduced. Copper serves as the anode. No, copper serves as the cathode. So D is wrong. And E says 2 of these. So our answer is E. 2 of them are correct. Number 60. In a car battery, which of the following is the electrolyte? Remember, the reactions in a car battery involve lead and lead oxide. And then there's a fluid between them. That is the electrolyte. The fluid in a car battery is sulfuric acid. Right? And remember that the lead acid battery doesn't require a bridge of any kind, salt bridge or a separation of some kind. Both the lead and the lead oxide plates are submerged in sulfuric acid. That's because the product of the reaction at the lead anode is lead 2 sulfate. And the product at the cathode, the lead oxide, is lead 2 sulfate. All right. Let's see. Why did I put that in there? Cell phone batteries. Cell phone batteries are based upon the lithium ion. Don't worry about that one. I'm not sure why I put that in there, just as a point of order. In the lead storage battery, PbO2 is found at the. Okay, so PbO2 is going to go to what? It's going to produce lead 2 sulfate. This is 2 plus, this is 4 plus. So what happened here? Well, we lost 2 electrons. Right? That's not a complete reaction, but it does help us answer the question. If we went from a 4 plus to a 2 plus, that means lead was oxidized. This is at the anode. All right. Wait a minute. Oxide. Oh, excuse me. No. It's reduced. That's the cathode. Yeah. Plus 4, 2 plus. Yeah, that's the cathode. I don't know what I was thinking. 63. Okay, I forgot to number that one correctly. That last one was 61. Now 63. When a metal corrodes, what's happening chemically? Well, when a metal corrodes, it's turning into a cation and losing electrons. Metal corrosion puts the metal as the anode, losing electrons, becoming oxidized. Metal atoms lose electrons. Yes, that is true. And since E says none of these and we found one that was, then the rest of them are irrelevant. We found one that was true. $66. All right, balancing the following redox equation in acidic solution. What's the coefficient of water? All right, methanol, CH3OH, plus dichromate ions. Yields CH2O. That's formaldehyde. Plus chromium 3 plus aqueous. Okay. So we got to find out which one's the oxidation step and which one's the reduction step. So this is, we'll start with this one. That chromium is 3+. This chromium, I think we did this one before, it should be 6+. So that's -14, -12 balanced, yes, +6. Okay. Oxygens, nothing happens to the oxygens. Hydrogens, nothing happens to the hydrogens. Let me see. Hydrogens might be affected. Yeah, hydrogens might be affected. Let's see what happens. Carbon is probably the issue here. So if this is +1, -2, +1, that's +3, -2, +1. So that's +2. This is -2. Yeah, I think it's carbon. -2 +1. So that's +2 -2, which is 0. Can that be right? 2 plus minus 2 plus. That's what it says. Yeah. I mean, it's not elemental, but our calculations tell us it's 0. All right, let's move on. So which one was oxidized? Well, carbon went from -2 to 0. So CH3OH with a -2 here goes to formaldehyde, CH2O, and that's a 0. And dichromate, O7, went from a +6 to 3+. Okay, in acidic solution. So we're going to balance the elements first. 2 chromiums here, we need 2 here. 1 carbon here, 1 carbon there. The rest are hydrogens and oxygens. So now we balance the oxygens. We need 7 oxygens on this side. Yeah, let's put it here. 7 waters. That's 14 hydrogens on this side. Okay, how about up here? 4 hydrogens, 2 there. So we need 2, let's say 1 oxygen here, excuse me, and 1 oxygen there. Well, oxygens are balanced already, but the hydrogens are not. So with 4 hydrogens, we need 2 more hydrogens over here, right? Okay, something messed up. Oh, I don't know why I didn't think of this. We've already got an oxygen here and oxygen there, but we need to balance the hydrogens. There are 4 on this side. We need 2 more hydrogens on this side. There we go. Now we're back in the game. Okay, now electrons. So we go from +6 to a 3+. That's 3 electrons for each chromium, which means we have to add 6 electrons because there are 2 chromiums. Okay, on this one, we went from a -2 we lost 2 electrons for each carbon. Okay, so that means we need 6 electrons in this one. That's 3 times. So that's 6, that's 6, that's 3, and that's 3. Okay. Now what's the coefficient for the, excuse me, coefficient for water? Here we go. There's water. Now the hydrogens are going to give us 8 hydrogens over here, but we still have only 7 waters. Right. So 7, that answers the question, 7 waters. If we were to say, all right, go down to 67, what's the coefficient for the hydrogen ions? Well, we've got 6 here, and we got 14 here. So that makes this one 8, and these are gone. So the coefficient for the hydrogen ions would be 8. Okay. All right. Number 70. How many electrons are transferred during this reaction when balanced? All right, we don't have any oxygens in there or hydrogen, so we don't have to do the half reaction method. We should be able to tie line. So this gold free chloride plus copper solid. This is aqueous. And then we have gold solid plus chloride in solution plus copper in solution. Okay. How many electrons are transferred? All right. This oxidation state is 0. This one's 0. That one's -1. This is 2 plus. So we just need to assess these. This is -1, so -4, but we have to hold out one of them. So this is +3. All right, what happens when we go from gold 3 plus to gold metal? That's a gain 3 electrons per gold. Copper, chloride doesn't change. So copper is the one that's oxidized. This is a loss of 2 electrons per copper. Okay. So how do we get the same number of electrons transferred when one of them's odd and one of them's even? Cross multiply. Take that 2 up here. Take that 3 down here. And that gives you 6 electrons. Okay. How do you get 6 electrons? If we were going to balance this equation, I mean, the answer is 6 electrons. But if we were going to balance this equation, in order to get 2 here, then we would have a 2 there. And a 2 here. And a 2 here. A 2. And a 2. Multiply the whole thing through by 2. No, that's not right. This is correct. 8 chlorides. 8 chlorides. and 2 coppers. That's correct. We also need 3 here, excuse me. That's not 2, that's 3. This is 3 because of that right there. So that should be balanced. But the transfer is 6 electrons. 71. How many electrons are transferred in this reaction? All right. 10 plus 2 hydrochloric acid yields 10,2 chloride plus hydrogen gas. So that's a 0. This is a 0. -1 plus 1, -1 plus 2. So when we go from this 10 to that 10, we lost 2 electrons per 10. Chlorine doesn't change. Hydrogen does change. We went from a +1 to a 0, so we had a gain of 1 electron per, per hydrogen. But there are 2 hydrogens. There we go. So 2 electrons were transferred. All right, 75. In an acid dry cell battery, for this reaction, we have what is oxidized. So we're going from zinc here plus ammonium chloride plus manganese 4 oxide yields zinc 2 chloride and ammonia. And Mn2O3, oops. Mn2O3 plus water. All right. Interaction. What is oxidized? That one's 0. This one's -1 plus 1. That nitrogen must be, let's see, +4. It must be -3. This is -2, so that's +4. -1, so this is +2. This is +1, so this is -3. And this is -2, so that's -6. 6 plus 3. And that's -2 and a +1. Okay, so something happened to the zinc. Right? The zinc lost 2 electrons per zinc atom. So that's oxidized. Oh, okay. There's our answer. Zinc is oxidized. So what's reduced? Well, nitrogen didn't change. It went from -3, -3. Chlorine didn't change. Oxygen didn't change. Manganese changed from +4 to +3. Manganese was reduced. Okay? But zinc is oxidized. Right. Next. There we go. 83. When the equation for the following reaction in basic solution is balanced, what's the sum of the coefficients? All right. So MnO2 plus HO2 minus yields MnO4 minus. All right, so what is this thing? Well, here's what I think it is. There's a hydrogen here, and this is a minus charge. So that's a peroxide. That means that each one of these oxygens is a -1 oxidation state. Now, does that figure? 2 times -1 is -2 plus 1. Yeah, -1. That works. Okay, how about manganese? -2, this is +4. This is a -2, -8 total, hold one out, -7, this is a +7. Okay. So now we know what to put in the oxidation step and the reduction step. The oxidation step is manganese. It goes from a +4 to a +7. Okay, that means that peroxide HO2 minus with this -1 here goes to what? Right. Well, it's got to go to something, right? So we have to add what it goes to. In this case, we got 1 manganese here on this side. We have 2 oxygens here and 4 there. So we need 2 more oxygens here. 2 plus 2 is 4. Now we need 4 hydrogens. Remember, this is in basic solution. So we're going to use my fake acid method. We're going to balance it acid and then change it to base. This one, how do we get 2 oxygens on that side? 2 waters. And we need 4 hydrogens over here, but we already have 1. So we only need 3 hydrogens on this side. Okay? Now we do electrons. This one lost 3 electrons. For each manganese. How about this one? Oxygen went from a -1 to a -2. It gained an electron for each oxygen, which means 2 electrons. Because we have 2 oxygens here, 2 oxygens there. So in order to go from -1 to -2, we need 1 electron per oxygen, but we have 2 oxygens, so it's 2 electrons. Okay, and the question was, what's the sum of the coefficients? All right, so we have to finish our equation. We have a 2 here and a 3 there. That means 2 there and 3 here. Okay, so this will be 6. This will be 8. That'll be 2. That'll be 4. And that'll be 2. This will be 6. This will be 9. This will be 3. And this will be 6. Okay. Now we balance the electrons. Well, we balance the electrons so we can add things together. So on this side, we have 2 Mn O2, 2 minus, right? Oh, excuse me. That 2 minus was for the oxygens. Okay. And then we have 4 waters. And the electrons are gone. We have 9 hydrogens. And we have 3 peroxide ions. So that's 1, 2, 3, 4. 1, 2, 3, 4. On this side, we have 2 MnO4 minus. And I can do better than that. There we go. MnO4 minus. And we have 8 hydrogens. And the electrons are gone. And we have 6 water. Okay. So let's reconcile some of this first. Waters. 4 on this side, 6 on that side. So that makes 2. We have 9 hydrogens and 8 hydrogens. Those are gone, and we're left with 1. Now we convert to base. We add hydroxyls. We only need 1 hydroxyl on this side and 1 hydroxyl on that side. So this makes water. And we've got 2 over there, 1 over here. So that water's gone. And now we only have 1 water. So add up the coefficients. 2. These are gone. Plus 3. Plus 2. Plus 1. Plus 1. What's that? 4, 7, 8, 9. Should be 9. Okay. 85. The following reaction occurs in basic solution. When the equation is balanced, the sum of the coefficients is. Well, isn't that nice? Silver plus copper yields silver metal plus copper 2+. This reaction is conducted in basic solution. Well, that's fine, right? But so what? Right? The hydroxyl is not part of the equation. So what we need to do is just balance it, right? So if we go from here to here, we have a gain 1 electron per silver. We go from here to here, we have a loss 2 electrons per copper. So how are we going to balance those 2? We need 2 silvers. There we go. So 2, 3, 4, 5, 6. The coefficient is 6. The sum of the coefficients is 6. Lots of practice. Oh, we're done. Those are the only ones that I had highlighted. But there's plenty more in there that you can practice. All right. So like I said at the beginning, Thursday, I'll zoom in for the first half hour in case anybody shows up to take the paper exam, or anybody that zooms in has questions about the exam. And then I'll shut the Zoom session down and I'll be available after that by way of my cell phone in case you have questions during the exam. And we have no new material to be introduced. So follow up next week. We'll do Tuesday and Thursday we'll use for review. And if required, we'll do half of them on Tuesday and half of the review on Thursday. You'll be ready for the following week for the final exam on Tuesday. All right.